Alright, today we are going to go over multiplying decimals. We are going to start with the standard algorithm for multiplying decimals first. So, it's pretty straightforward. Basically, the method I would suggest is ignoring, sorry, that looks kind of like a comma there. Ignoring the decimal at first. Okay, so 5.4 or 5 and 4/10 times 6.2 or 6 and 2/10. First thing I would do is just ignore the decimals. Multiply it exactly like you would at 54 times 62. So 2 times 4 is 8. 2 times 5 is 10. I put a 0 here because this is for 60, not 6. And then 6 times 4 is 24. I carry the 2. 6 times 5 is 30 plus 2. Alright, and now I just add these up. 8, 4, 3, 3. Okay, so we have the answer for 54 times 62. But these are not 54 times 62. This is 5 and 4/10 times 6 and 2/10. So what do we have to do? We have to see how many numbers are, or how many digits are on the right side of the decimal. And in this case, it's 1 in this one and 1 in this one. So we add these up to be 2. We don't add the digits up. But there are 2 digits past the decimal system. And that means that we have to move the decimal 2 digits over. So the answer is 33 and 48/100. That's all it is. You do the normal algorithm, and then all you do is move it over the amount of digits that are on the right side of the decimal. So let's just do this one. So 23 and 2/10 times 6/100. So what we're doing here is I'm basically going to, I can put these decimals here just for, just for completeness, but really all I'm doing is I am multiplying 6 times 232 as the first thing. So I do 6 times 2 is 12. I carry the 1. 6 times 3 is 18, plus 1 is 19. 6 times 2 is 12, plus 1 is 13. Alright, so now I have to figure out how many digits are after the decimal. So we have 1, 2, 3. So that means I have to have 3 digits after the decimal in the answer. So I put the decimal right there. 3 digits after the decimal in the in these, and then 3 digits here, right? So that's it. And the answer is 1 and 392 thousandths. So let's say I do 23 times 6.4 or 6 and 4/10. 4 times 3 is 12. Carry the 1. 4 times 2 is 8, plus 1 is 9. Put the 0 here. 6 times 3 is 18. 6 times 2 is 12, plus 1 is 13. I add these up. 2. I'm sorry. 9 plus 8 is not 19. 9 plus 8 is 17. 1 plus 3 is 4, and then 1. And then since there is only one digit on the other side of the decimal in both these numbers, I have to move it to here. And the answer is 147 and 2/10. Now, one way to think about this is you can estimate these, right? So 6 and 4/10 is close to 6. So this answer should be close to 6. So 23 times 6 equals 138, I think. Don't quote me on that. I did it quickly in my head, so I think that's correct. But that's close to 147 and 2/10. Now, if 23 times 6 is 138, and all of a sudden I get 14,720 as the answer, well, that is not at all close to 138. So it's not a bad idea to just estimate afterwards so you have an idea. Like this one, what's 5 times 6 is 30, right? So 5 and 4/10 would round down to 5. 6 and 2/10 would round down to 6. So 5 times 6 is 30. So the answer is close to 30, right? 23 and 2/10 times 6 600ths. This one's a little tricky. It would actually be similar to dividing this number by I don't know, something like 17, I guess, or 16, something like that. Anyway, but yeah, so just it's always good to estimate in these scenarios to make sure that the answer makes sense.